Today, inshallah, we are going to start chapter 7. Chapter 7 talks about sampling and sampling distributions. The objectives for this chapter are, number one, we have different sampling methods. Actually, we have two methods, probability and non-probability samples, and we are going to distinguish between these two sampling methods. So again, in this chapter, we'll talk about two different sampling methods. One is called probability sampling, and the other is non-probability sampling. Our goal is to distinguish between these two different sampling methods. The other learning objective will talk about the concept of the sampling distribution. That will be next time, inshallah. The third objective is to compute probabilities related to sample mean. In addition to that, we'll talk about how can we compute probabilities regarding the sample proportion. And as I mentioned last time, there are two types of data. One is called the numerical data. In this case, we can use the sample mean. The other type is called qualitative data, and in this case we have to use the sample proportion. So for this chapter we are going to discuss how can we compute the probabilities for each one, either the sample mean or the sample proportion. The last objective of this chapter is to use the central limit theorem, which is one of the most famous theorem in this book, which is called again CLT, central limit theorem, and we are going to show what is the importance of this theorem. So these are mainly the four objectives for this chapter. Now let's see why we are talking about sampling. In other words, most of the time when we are doing study, we are using a sample instead of using the entire population. Now there are many reasons behind that. One of these reasons is selecting a sample is less time consuming than selecting every item in the population. I think it makes sense that suppose we have a huge population, that population consists of thousands of items. So that will take more time if you select 100 of that population. So time consuming is very important. So number one, selecting a sample is less time consuming than using all the entire population. The second reason, selecting sample is less costly than selecting every item in the population. Because if we have large population, in this case you have to spend more money in order to get the data or the information from that population. So it's better to use this sample. The other reason is the analysis of a sample is less cumbersome and more practical than analysis of all items in the population. For these reasons, we have to use a sample. For this reason, we have to talk about sampling methods. Let's start with sampling process that begins with a sample frame. Now, suppose my goal is to know the opinion of IUG students about a certain subject. So my population consists of all IUG students. So that's the entire population. And you know that, for example, suppose IUG students is around, for example, 20,000 students. 20,000 students is a big number. So it's better to select, it's better to select a sample from that population. Now the first step in this process, we have to determine the frame of that population. So my frame consists of all IU students, which has maybe males and females. So my frame in this case is all items, I mean all students at IUG. So that's the frame. So my frame consists of all students at IUG. So the definition, sorry. The definition of the sampling frame is a listing of items that make up the population. The items could be individual, could be students, could be things, animals, and so on. So frames are data sources such as a population list. Suppose we have the names of IUG students. So that's my population list. Or directories, or maps, and so on. So that's the frame we have to know about the population we are interested in. Inaccurate or biased results can result if frame excludes certain portions of the population. For example, suppose here, as I mentioned, we are interested in IUG students, so my frame is all IUG students. And I know that students, either males or females. Suppose for some reasons we ignored males and just my sample focused on females. In this case, females don't represent the entire population. For this reason, you will get inaccurate or biased results if you ignore a certain portion, because here males, for example, maybe consist of 40% of the IUG students. So it makes sense that this number or this percentage is big number. So ignoring this portion may lead to misleading results or inaccurate results or biased results. So you have to keep in mind that you have to choose all the portions of that frame. So inaccurate or biased results can result if a frame excludes certain portions of a population. Another example, suppose we took males and females, but here for females, females have, for example, 4 levels. Level 1, level 2, level 3, and level 4. And we ignored, for example, level 1. The new students. We ignored this portion. Maybe this portion is a very important one, but by mistake we ignored this one. The remaining 3 levels will not represent the entire female population. For this reason, you will get inaccurate or biased results. So you have to select all the portions of the frames. Using different frames to generate data can lead to dissimilar conclusions. For example, suppose again I am interested in IUG students, and I took the frame that has all students at Universities of Gaza. And as we know that Gaza has 3 universities, big universities. Islamic University, Al-Azhar University, and Al-Aqsa University. So we have 3 universities. And my frame here, suppose I took all students at these universities, but my study focused on IUG students. So my frame, the true one is all students at IUG, but I took all students at Universities of Gaza. So now we have different frames. And you want to know what are the opinions of the smokers about smoking. So my population now is just smokers. So my
frame is all smokers. So that's my frame. But suppose I talk to the frame that has all adults. All adults. Now we have different frames. The first one consists of all smokers that I am interested in. The other one consists of all adults. Adult maybe smoker or non-smokers. For this reason, you will get different conclusions. So, conclusion with different results. عارفين معنى conclusion؟ استنتاجات معينة. So now the sampling frame is a listing of items that make up the entire population. Let's move to the types of samples. Mainly there are two types of sampling. One is called non-probability samples. The other one is called probability samples. The non-probability samples can be divided into two segments. One is called judgment and the other convenience. So we have judgment and convenience non-probability samples. The other type, which is non-probability samples, has four segments or four parts. The first one is called simple random sample. The other one is systematic. The second one is systematic random sample. The third one is certified. The fourth one, cluster random sample. So there are two types of sampling: probability and non-probability. Non-probability has four methods here: simple random sample, systematic, stratified, and cluster. And the non-probability samples has two types: judgment and convenience. Let's see the definition of each type of samples. Let's start with non-probability sample. In non-probability sample, items included or chosen without regard to their probability of occurrence. So that's the definition of non-probability. For example, so again, non-probability sample, it means you select the items without regard to their probability of occurrence. For example, suppose females consist of 70% of iugaza students, and males the remaining percent, which is 30%. And suppose I decided to select a sample of 100 or 1,000 students from iugaza. Suddenly I have a sample that has 650 males and 350 females. Now this sample, which has these numbers, for sure does not represent the entire population, because females has 70%, and I took a random sample or a sample of size 350. So this sample is chosen without regard to the probability here, because in this case I should choose males with respect to their probability, which is 30%. But in this case I just choose different proportions. Another example. Suppose, again, I am talking about smoking. And I know that some people are smoking. I just took this sample. So I took this sample based on my knowledge. So it's without regard to their probability. Maybe suppose I am talking about political opinions about something, and I just took the experts of that subject. So my sample is not a probability sample. And this one has, as we mentioned, has two types. One is called convenience sampling. In this case, items are selected based only on the fact they are easy. So I choose that sample because it's easy. Inexpensive, or convenient to sample. If I choose my sample because it is easy or inexpensive, I think it doesn't make any sense. Because easy is not a reason to select that sample. Inexpensive, I think, is not that big reason. But if you select a sample because these items are convenient to a sample, it makes sense. So convenient sample can be chosen based on easy, inexpensive, or convenient to sample. On the other hand, in judgment sample, you get the opinions of pre-selected experts in the subject matter. For example, suppose we are talking about the causes of certain disease. Suppose we are talking about cancer. If I know the expert for this type of disease, that means you have judgment sample, because you decide before you select a sample that your sample should contain only the expert in cancer disease. So that's the judgment sampling. So in this case, I didn't take all the doctors in this case. I just took the expert in cancer disease. So that's called non-probability sample. So we have to make sense to distinguish between convenient sampling and judgment sample. So for judgment, you select a sample based on the prior information you have about the subject matter. Suppose I am talking about something related to psychology, so I have to take the expert in psychology. Suppose I am talking about expert in sports, so I have to take a sample from that segment and so on. But the convenient sample, it means that you select a sample maybe that is easy for you, or less expensive, or that sample is convenient. For this reason, it's called non-probability sample, because we choose that sample without regard to their probability of occurrence. The other type is called probability samples. In this case, items are chosen on the basis of known probabilities. For example, here, if males has or represent 30% and females represent 70%, and the sample size has 1,000, so in this case you have to choose females with respect to their probability. Now 70% for females, so I have to choose 700 for females and the remaining 300 for males. So in this case, I choose the items, I choose my samples regarding to their probability. So in the probability sample, items and the sample are chosen on the basis of known probabilities. And again, there are two types of probability samples: simple random sample, systematic, stratified, and cluster. Let's talk about each one in details. The first type is called a probability sample. Simple random sample. The first type of probability sample is the easiest one. Simple random sample. Generally is denoted by SRS. Simple random sample. Let's see how can we choose a sample that is random. What do you mean by random? عشوائي. In this case, every individual or item from the frame has an equal chance of being selected. For example, suppose number of students in this class, number of students is 52. So each one, each student from 1 up to 52 has the same probability of being selected.
1 by 52.
1 by 50. 1 divided by 52. So each one has this probability. So the first one has the same, because if I want to select, for example, 10 out of you,
10 by...
so the first one has, each one has a probability of 1 out of 52. So that's the meaning of each item from the frame has an equal chance of being selected. Selection may be with replacement. With replacement means selected individuals is returned to the frame for possibility selection, or without replacement means selected individuals or item is not returned to the frame. So we have two types of selection, either with, so with replacement means item is returned back to the frame, or without population the item is not returned back to the frame. So that's the two types of selection. Now, how can we obtain the sample? Sample obtained from something called table of random numbers. In a minute I will show you the table of random number. And the other method of selecting a sample by using computer random number generators. So there are two methods for selecting a random number. Either by using the table that you have at the end of your book, or by using a computer. I will show one of these. And in the SPSS course, we will see another one, which is by using a computer. So let's see how can we obtain a sample from table of random number. I have maybe different table here, but the same idea to use that table. Let's see how can we choose a sample by using a random number. Now, for example, suppose in this class, as I mentioned, there are 52 students. So each one has a number, ID number 1, 2 up to 52. So the numbers are 01, 02, all the way up to 52. So the maximum digits here, two digits. 0, 1, 2, 3 up to 52, so we have 2 digits. Now suppose I decided to take a random sample of size, for example, instant. How can I select 10 out of you? In this case, each one has the same chance of being selected. Now, based on this table, you can pick any row or any column randomly. For example, suppose I select the first row. Now, the first student will be selected is student number to take 2 digits. we have to take how many digits? Because students has ID card that consists of 2 digits, 01, 02 up to 52. So what's the first number of students will be selected based on this table? Forget about the line, 101. Start with this number. So the first one, 19. The second, 22. The third student, 19, 22, 39. 39. I'm taking the first row. Then 50. 34. 34. 04. Student number 05. اللي بعده 34 05. Now, what's about 75? 75 is not selected because the maximum I have is 52. Next. 62 is not selected. 62, 87 is not selected. 13 is okay. Next, 96 not selected. 40 is okay. 91 not selected. 91 25 31. So that's 10. So students' numbers are 19, 22, 39, 50, 34, 5, 13, 40, 25, and 31 will be selected. So these are the ID numbers will be selected in order to get a sample of 10. Yes. You exclude that one. If the number is repeated, you have to exclude that one. So if the number is repeated, then exclude. So returned number must be excluded from the sample. Okay. Let's imagine that we have not 52 students. We have 520 students.
001.
Now, I have large number, 52, 520 instead of 52 students. And again, my goal is to select just 10 students out of 120. So each one has ID with number 1, 2, all the way up to 520. So the first one, 001, 002, all the way up to 520. Now in this case, you have to choose 3 digits. Start, for example, you don't have actually to start with row number 1, maybe column number 1, or row number 2, whatever is fine. So let's start with row number 2. For example, row number 2, 736 is not selected because the maximum number I have is 520. So 746 shouldn't be selected. The next one, 764, again is not selected. 764, 715, not selected. Makes sense? 715, 099 should be selected. And so on. Okay, so that's the way how can we use the random table for using or for selecting simple random sample. So in this case, you can choose any row or any column. Then you have to decide how many digits you have to select. It depends on the number you have. I mean the population size. If, for example, suppose I am talking about IUG students, and for example we have 30,000 students at this school. And again, I want to select a random sample of size 10, for example. So how many digits should I use? 20,000. 5 digits. And each student has ID start from the first one up to 20,000. So now, start with, for example, the last row we have. The first number, 54,000 is not. 81 is not. None of these. Look at the next one. 71,000 is not selected. Now 9001. So the first number I have to select 9001. None of the rest. Go back. Go to the next one. The second number, 12,149, and so on. Next will be this one, 18,000, and so on. Next row, we can select the second one. Then 16, then 14,000, 6,500, and so on. So this is the way how can we use the random table. It seems to be that tons of work if you have large sample, because in this case you have to choose. For example, suppose I am interested to take a random sample of 10,000. Now, to use this table to select 10,000 items takes time and effort, and maybe will never finish. So it's better to use computer random number generators. So that's the way. Now we can use the random table only if the sample size is limited. I mean, up to 100 maybe you can use the random table, but after that I think it's just you are losing your time. Another example here. Now suppose my sampling frame for population has 850 students. So the numbers are 001, 002, all the way up to 850. And suppose, for example, we are going to select 5 items randomly from the population. So you have to choose 3 digits. And imagine that this is my table, or this portion of that table. Now, take 3 digits. The first 3 digits, 492. So the first item chosen should be 400, item number 492. Should be selected. Next one, 808. Doesn't select. Because the maximum, this one selected. Because the maximum is 850. Now next one, 892. This one is not selected. Next item, 435, selected. Now 779 should be selected. Finally, 002 should be selected. So these are the 5 numbers in my sample selected by using the random sample. Any questions? Let's move to another part. And the next type of samples is called systematic samples. Now suppose N represents the sample size, capital N represents the population size, and let's see how can we choose a systematic random sample from that population. For example, suppose for this specific slide there are 40 items in the population, and my goal is to select a sample of size 4 by using systematic random sample. And the first step is to find how many individuals will be in any group. Let's use this letter K, divide frame of n individuals into groups of k individuals. So k equal capital N over small n. This is number of items in a group. So k represents number of subjects or number of elements in a group. So for this example, k equals 40 divided by 4, so 10. So the group, each group has 10 items. So each group has 10 items. So group number 1, 10 items. And the others have the same number. So first step, we have to decide how many items will be in the group, and that number equals n divided by small n, capital N divided by small n. In this case, n is 40, the sample size is 4, so there are 10 items in each group. Next step, select randomly the first individual from the first group. For example, here, now how many we have here? We have 10 items, so numbers are 01, 02 up to 10. I have to choose one randomly from these numbers, from 1 to 10, by using the random table again. So I have to go back to the random table and I choose 2 digits. Now the first one is 19, 22, 39, 50, 34, 5. So I have to, so number 1 is 5. What's the next one? The next one, just add k. K is 10. So next is 15. There, 25. Then 34.
Sample size consists of 4 items. So the first number is chosen randomly by using the random table. Then the next number, just add the step. This is step. So my step is 10 because number 1 is 5. The first item I mean is 5. The next should be 15, 25, 35, and so on if we have more than that. Okay, so that's for, in this example, he chose item number 7. Randomly selection, number 7. So next should be 17, 27, 37, and so on. Let's do another example. Suppose
there are, in this class, there are 50 students. So the total is 50. 10 students out of 50. So my sample is 10. Now step 50 divided by 10.
So there are 5 items or 5 students in a group. So we have 5 in the first group, and then 5 in the next one, and so on. So we have how many groups? 10 groups.
So first step, you have to find the step. Step, it means number of items or number of students in a group. Next step, select a student at random from the first group. So randomly selection. Now, here there are 5 students, so 0, 1, I'm sorry, not 0, 1. 1, 2, 3, 4, 5, so 1 digit. Only 1 digit, because I have maximum number is 5, so it's only 1 digit. So go again to the random table and take 1 digit, 1. So my first item, so 6, 11, 16, 21, all the way up to 10 items. So
You have 2, 4, 6, 8, 9, 46. So I have to choose student number 1, then skip 5, choose number 6, and so on. It's called systematic, because if you know the first item and the step, you can know the rest of the.
Imagine that you want to select 10 students who entered the coffee shop or restaurant. You can pick one at
random. So suppose I'm taking number 3, and my step is 6. So 3, then 9, and so on.
So that's systematic assembly. Questions? So that's about random samples and systematic assembly. What do you mean by stratified? Groups or طبقات, شرائح. Let's see the definition and an example of stratified sampling. Step 1. So again, imagine we have IUG population into 2 or more subgroups. So there are 2 or more. It depends on the characteristic you are using. So divide population into 2 or more
Subgroups according to some common characteristic. For example, suppose I want to divide IUG student into gender. So males or female. So I have 2 strata. One is called males and the other is females. Now suppose the characteristic I am going to use is the levels of a student. First level, second, 3, 4, and so on. So number of strata here depends on actually
the characteristic you are interested in. Let's use the simple one, that is gender. So here we have females. So IUG students divided into two types, strata, or two groups, females and males. So this is the first step. So at least you should have two groups or two subgroups. So we have IUG student, the entire population, and that population divided into two subgroups. Next, a simple random sample is, keep careful here, with sample sizes proportional to strata sizes. That means, suppose I know that female
of 70% of IUG students and males 30%.
The sample size we are talking about here is, for example, is 1,000. So I want to select a sample of 1,000 students from the registration office, or my information about that is males represent 30%, females represent 70%. So in this case, your sample strata
should be 70% times the sample size.
So 70% times 1,000. That will give 700. So the first group should have 700 items or students, and the other one is 300,000. So this is the second step. So now, sample sizes are determined in step number 2. Now, how can we select the 700 females here? Again, you have to go back to the random table. Samples from subgroups are combined into one. Then you can use simple random sample. So here, 700. I have, for example, 70% females, and I know that I use student here. I have IDs numbers from 1 up to 14. Then by using simple random table, you can
Choose the 700 students. So if you go back to the table, the first item,
now look at 5 digits. 19 is not selected. 19. I have the maximum is 14,000. So skip 1 and 2. The first item, 1,756. The first item. Next is not chosen. Next is not chosen. Number 6, 12.
12,500.
and so on. So here we divided the population into two groups or two subgroups, females and males, and we select a random sample of size 700 based on the proportion of this subgroup.
Then we are using the simple random table to take the 700 females. Now for this example, there are 16 items or 16 students in each group, and he selects randomly number 3, number 9, number 15, and so on. So it's randomly selection. Another example. Suppose again we are talking about all IUB students.
here I divided the population according to the students' levels. Level 1, level 2, so levels 1, 2, 3, and 4. So I divide the population into 4 subgroups according to the student levels. So 1, 2, 3, and 4. Now, a simple random sample is selected from each subgroup with sample sizes proportional to strata size. Imagine that level number 1 represents 40% of the students. Level 2, 20%. Level 3, 30%. 10%. Just an example. To make more sense, okay. My sample size هذول randomly أي 3 9 15 4 I'm sorry 4
So again, there are 4 levels, and the proportions are 40, 30, 20, and 10.
Sample size is 500. So the sample for each strata will be number 1, 40% times 500 gives 200. The next 150 and so on. Now, how can we choose the 200 from level number 1? Again, we have to choose the random table. Now, 40% from this number, it means 5,000. This one has 5,600 females students. Because 40% of females in level 1. And I know that the total number of females is 14,000. So number of females in the first level is 5,600. How many digits we have? 4 digits. The first one 001 all the way up to 560. If you go back into the random table, take 4 digits. So the first number is 1922. Next is 3950. And so on. So that's the way how can we choose stratified samples. Next, the last one is called cluster sample. And let's see now what's the difference between stratified and a cluster. Step 1. Population is divided into some clusters.
Step 2. Assemble random sample of clusters is selected. Here suppose how many clusters?
16 clusters. So the population has 16 clusters.
16 clusters. Step 2, you have to choose a simple random number of clusters out of 16. Suppose I decided to choose 3 among these. So we have 16 clusters. For example, I choose cluster number 4, 11. So I choose these clusters. Next, all items in the selected clusters can be used. I mean,
all items can be chosen from a cluster using another probability sampling technique. For example, imagine that we are talking about students who registered for accounting.
Imagine that we have 6 sections for accounting. So there are 6 sections. And I just choose 2 of these. Cluster number 1 or section number 1 and the last one. So my chosen clusters are number 1 and 6. 1 and 6. Or you can use the one we just talked about, stratified random sample, instead of using all. For example, suppose there are, in this section,
there are 70 students, and the other one, there are 80 students. And the sample size here, I am going to use as 20.
so you can use 10 here and 10 in the other one. Or it depends on the proportion here. Now, 70 represents 70 out of 150, because there are 150 students in these 2 clusters. Now, the entire population is not the number for each of all of these clusters, just number 16. So there are 150 students in these 2 selected clusters. So the population size is 150. Make sense? Then the proportion here is 700 divided by 150 times 20. The other one, 80 divided by 150 times 20. That will give the actual values. So again, all items in the selected clusters can be used, or items can be chosen from the cluster using another probability technique as we mentioned. Let's see how can we use another example. Let's talk about again iugaza students. And we have 4 levels. I choose, suppose, level number 2 and level number 4. 2 levels, 2 and 4. Then you can take either all the students here or just a sample size in proportion to the students in level 2 and level 4. For example, this one represents 20%, and my sample size is 1,000. So in this case, you have to take 200 and 800 from that one. Any questions? So that's for